Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're out in the shop and we are working on the Kearney Trekker Model 3H horizontal milling machine. And I had previously got this vertical head set up on here all trimmed in, ready to do a job on some brass bronze bearings for a steam locomotive that we're working on making some new bearings for. And ran into a problem before I ever even got started. I guess, guys, I just didn't really do my homework here well enough, and I had planned on coming in here and having this extra heavy duty setup with the horizontal mill, really stout, sturdy, setup here to mill out these slots on the inside. But I quickly discovered that with the height of my vise, the height of the part sticking up, the end mill holder and everything else, I don't have enough room in here. You can see my end mill sticking way down farther. Yeah, I could get a shorter end mill, but I don't have one. I'd have to go buy one. That's going to be a couple of $100. So I'm looking for other options on how to get this job done. So, and I think I've got one, and we're going to go over that in just a second. But did want to just kind of show you that, hey, this was plan A. Like a lot of times in the machine shop, you come up with plan A and plan A doesn't work out like you wanted to. So you go to plan B and then to plan C and so on and so on. So what am I going to do? Instead of using the vertical head here, I think we're just going to try to do this using the horizontal feature. So I've got some brand spanking new wheel cutters here that a viewer had sent in a while back. These are new old stock. This is a 1-inch wide cutter, never been used, razor sharp. I think we're going to set this thing up in horizontal mode and just try to come in here and cut them out that way. This is actually kind of something that I had thought about from the very beginning, but for a couple of different reasons, I really kind of thought that, if we could do this with the vertical, I thought it might be better. And anyway, we're at where we're at here, and I think we're just going to switch over and try to do this in horizontal mode, which will be fine. Another option that I considered is I could rotate this head around where basically the cutter was sticking out horizontally and go up and down, but that poses some more challenges down the road, particularly with setup. I want to make sure that the top and the bottom of these, so basically this side and this side, are parallel. And if I'm working off of the top, I can, after I get one side cut, I can flip it over and put it on some parallels up underneath the bottom and then do the top, and they should come out parallel with one another. If I'm doing them on side by side, I don't really have anything an easy way for me to set this thing up other than sweeping an indicator on one side to try to get it where it's set up parallel on the other side. And then with tool pressure and everything else, the part could move around. I think it's just not the best way to do it. So I would rather be working on the top of the part in this situation, so that's kind of my game plan. I'm going to get the vertical head taken back off of this machine, and we're going to get a horizontal arbor set up on here, and I'll bring you guys back, and we'll see what we can do, see if we can get this accomplished. I think this will be a fun horizontal project. So one of the really cool things about these horizontal milling machines is how you can reconfigure them to do just all kinds of jobs. We just had a vertical universal head on here that could rotate in any angle in 2 different axes. We took that off. Now we've got a horizontal cutter on here. It took me 45 minutes to swap this over. Probably should have shot video of it, but you guys, if you watch my channel regularly, you've seen me set up a horizontal arbor before. It's not a big deal. But basically what we got here, this is a 6-inch diameter cutter. This is on an 1.25 inch arbor. So the arbor size is 1.25 inches on the inside. We just got some spacers in here to kind of block it in. There's a key on the inside of this that drives it. And we got an overarm support out here that supports it. So it's supported on both the front and the back. And of course this cutter just rotates and your work moves up underneath it, and it can hog some metal out. First thing I needed to do was figure out what RPM I need to run this at. So I've got a little little calculator here from Kearney Tracker, and I look up on here and it tells me that for bronze, which is the material that we're going to be cutting with a high-speed steel cutter, which is what we have here, the surface speed in feet per minute it recommends is between 200 and 300 feet per minute. Now that's the speed out here on the surface of the diameter of this cutter. It needs to be running about 200 to 300 feet per minute. So I'm going to flip this thing over, and I'll tell you what, I'll zoom in here and I'll show you how I'm going to calculate this out. So the first thing we're going to do is we look up here where A, and we're going to put our cutter diameter in here. So I'm going to roll this over to 6 inches. I line that up right there. Now I look down here on the bottom and I'll say, okay, what surface speed in feet per minute do I want? Remember, we're between 200 and 300. I tend to go toward the conservative side of this. So I'm going to say 200 feet per minute. And I can look in here and I can tell that it needs to be about 125 RPMs to get that surface speed on a 6-inch cutter. So I've got my machine set on 124, which was 1 RPM off of what it reads directly. So that should give us the proper speed. Again, I am on the conservative side. I can go up to 300 feet per minute, which would be about 190 RPM. So, we are on the low end of that range. On a, small job like this, not a huge production job, I tend to run a little bit conservative on my speeds and feeds. If this was a production job, we were going to be setting this machine up and fine tuning it and cranking out the same part over and over and over again, I'd probably be pushing the upper end just from a speed and efficiency standpoint. But typically, even when you're doing that, you kind of start slow and kind of figure out where it needs to be through trial and error. In that range. So we're just going to start on the lower end. All right, let's show you our work over here. Now we're trying to get our cutter kind of figured out where we need to start at. First off, that's what the speed looks like, 124 RPM. What I'm going to do is I've already kind of come in here and I just barely kind of touched off in the lower end here. Of course, this is a rough casting, so it's very irregular. But that should be at least hitting in a few places there. I am below the surface here. So what I'm going to do is I'm just going to kind of bring my table in and I want to kind of touch the back side of that cutter up against the wall. That just kind of gives me, again, a starting point. Okay, I can hear it barely touching right there. So now what I'm going to do is we're going to move our cutter out. And let me do a little figuring on our depth and all that, and we're going to make a first pass through here. All right, so according to my blueprints, this wall over here should be 3/8 of an inch, which is 375 thousandths. We're running right now about 475 thousandths, so I got about roughly 100 thou I need to take out of there. And again, I'm measuring on a rough casting, so it's hard to get a precision measurement at this point. We're just getting kind of rough measurements right now. I think what I'm going to do is we're going to make a pass down through here. I'm going to feed over 50 thousandths into there. That gives me enough to clean that up, but also enough that I can make another measurement after we make our first pass and go from there. The other measurement here is the depth, and from the top of this piece that we've already got machined down to the bottom of what will be the part we're milling out, I believe it's a 1/2 inch. Let me verify that real quick on the blueprint. Yeah, so it's a 1/2 inch. So, and what's important is the total thickness of this needs to be 4 inches. Right now, the thickness of the outside is 5 inches. It's not so much the heights to the bottom of this, but it's more the thickness of this centerpiece. We'll worry about that when we flip it over. But right now, I need to take roughly 1/2 inch off the surface up here. So again, I kind of just touched off in here to kind of get me a rough idea. We're basically 150 thou is where the cutter's at right now. I'm just gonna feed in another 100 thou. Let me look and see right here. Yeah, I'm gonna feed in 100 thou on the depth, and that should at least get me, again, cleaning up in the bottom here. Once I get some machine surfaces, I can make precision measurements and do a better job of fine tuning where we need to go. But right now I just need to establish some reference surfaces to work off of. So I'm going to zero out my dials on the milling machine. Again, we're going to dial in 50 thousandths, down 100 thousandths, and I think we should have a starting point. So let me do that, and we'll make our first pass. I think we're ready to roll here. See what happens. Now, as far as feed rate, according to the calculations, again, a conservative feed rate on this is about 7 inches per minute, which is, I'm starting way below that. I'm on 4.5 inches per minute right now. And we'll play around with our feed rate. Again, I tend to want to start on the conservative side, and we can always speed things up if it'll take it. So let's see how this cuts. So we're starting into the cut there. Fairly light cut right now, but it is eating it like butter. Ideally, we would be using flood coolant. I really don't have this machine set up to use flood coolant right now. I'm not even sure if the coolant pump works on this machine, to be honest with you. That may be something we have to look into at some point. We may have to look into that before this job's over, but I'm going to try cutting it dry if I can get away with it. All right, we're about to get into the bottom of the cut down there. Let's see if we're going to touch off. Yeah, it's starting to hit the bottom. Cranking out a little bit more metal now. The cutter is cutting a little bit heavy in one area, as you can tell. It's not unusual. Usually it's hard to get a perfectly straight arbor, to be honest with you. It's not that big of a deal to worry about. It's going to cut uniform. It's just cutting a little bit harder on a couple of the teeth there than it is on the other, which is why, slowing down your feed rate will help, because you're not cutting the same amount on every single tooth as that thing's coming around. It's cutting heavier on one side, so slower feed rate will compensate for that. I'm gonna go ahead and take it back over. Come in here and get some good measurements now. So it looks like we're about 437. 440. Let me get up here and measure this again. Yeah, 440. So roughly 440 in that direction. The depth here, a little over 1/4 of an inch. So we got about half the depth to come out, or right on 1/4 of an inch. So we're going completely old school here. No digital readout on this milling machine, so we're working off the dials. So you've got the dials and they're calibrated. According to my measurements, I need to move the table into me 65 thousandths, so we need to go 250 thousandths deeper, which means we'll need to raise the table up 250 thousandths. So I'm going to start here on this one, and we're going to do 65 thousandths. So I'm starting at 0. You can loosen a set screw here and adjust this to where you start on a 0. So loosen that table up. So that's 10, 20, 30, 40, 50, 60, 5 right there. I'm going to lock my table back down. Then I need to come up 250 thousandths. Let me loosen this table up. Loosen the knee up. Again, I'm starting on 0. This one in one turn is 100 thousandths. 2 turns is 200 thousandths, and we'll come around to 50 right there. And we'll relock that table, and we should be ready to make our next pass. All right, here we go. Pass number 2, we're going to be making a good bit more cut in the bottom, not so much on the side. Let's see how she does. We may play around with our speeds and feeds as it's cutting. We'll just kind of listen to it and see what kind of finish we're getting. In fact, I'm just going to go ahead and be conservative. I'm going to drop it down to 3 3/8 inches per minute. I didn't like the surface finish down there in the bottom of that cut. So I'd rather just take my time, make sure we get it right. So far, so good. Let's see what it looks like when it gets over here in this bottom of the cut. All right, we're about to get into the bottom. You hear the change in the sound. Just chewing it up and spitting it out. I think the finish that we're seeing on there is acceptable, so we're just going to probably let it roll. And I probably need to get some cutting oil or something to put on it. I'll probably just wait and do that on the next pass. All right, I think we're past our center, so we'll come back across this. Actually got a fair amount of chatter just going back across it there, but that's going to be fine on the surface finish. Most of that we put in there coming back across. I guess I could let it ease across in a climb milling cut to smooth that up. Let me get some measurements and we'll go from there. I'm ready for my next pass. I've really got about an inch to come over, and this is a 1 inch wide cutter, but I think I'm gonna do it in 2 passes. I'm gonna do 50,000 or 500 thousandths, half inch, and then come in and do the final cut. I also put a cool mist on here. This is just a little bit of coolant, not really coolant, but it's a cool mister, so it will help with from the coolant standpoint, keeping the part cool, and as well as giving it a little bit of lubrication. So we're gonna give that a try. I've already moved my cutter over. Let's go ahead and get this in here. We'll a little bit of a light mist. And let it roll on through there. All right, I am going to just kind of let my cutter back feed across there. We're climb milling right now. When I say climb milling, it's trying to, if the didn't have any backlash in the part, the cutter would want to climb up onto the part, which can be a little bit dangerous if you got a wore out machine. Because I'm really not feeding in, I'm just barely cutting anything off. I'm not too worried about it. Even if it were to climb up on there, it wouldn't hurt anything. I'm safe in this situation, but that I think will help kind of just clean up that bottom and make it like it needs to be. So anyway, we're going to go ahead and feed that back across. We'll get a good measurement here and we'll make our final pass through there. All right, here we go, one more time. This should be the last pass on this side. Because I think we got our first one cut here. Everything checks out dimension-wise. I think what we're going to do next is go ahead and do our next surface. We're just going to have to rotate this part around and around and around until we get everything done. So I think I'm just going to literally work myself around rather than going to the other side. We're just going to flip it up and do this next top part here. I think that'll help me make sure I keep my edges the same all the way around. That's the game plan anyway. So let's go ahead and first off, get a brush here. Just try to get as many of these chips out of here as we can. I've already cleaned it up a little bit. All right, let's open her up. Hi guys, I'm getting brave. As you can see, I've added a second cutter to this. And what we're going to attempt to do is make the entire width in one pass. That would keep me from having to move the table in and out. I can kind of get my back set where I want it to get this thickness right and come in here and cut the whole thing. So this cutter is a stagger tooth cutter. If you notice, one side cuts over a little bit farther than the other side, and the rake of the teeth alternate back and forth. When you stack these together, even though there's a gap between these two, this tooth over here is coming in, and vice versa. So really, the edge of these two teeth should match up flush across the bottom, assuming the cutter's in good shape. These are brand new cutters, so they should be. And each cutter's 1 inch thick, so when we stack them together, we should have a 2 inch thick cutter. That's the game plan. So I think we'll be fine doing this. This will just save me a little bit of trouble. I'm just kind of easing into this, kind of checking things out as we go. This is kind of my plan all along, to eventually get to this where we could do this. So we're going to give it a try. See how it goes. If it doesn't sound like it's working out, we can always go back to just using one cutter. So I've got my edges lined up again. We should be ready to come through here and make another pass. So let's give it a try. All right, we got that first pass. Again, I want to come through this thing and make some measurements, figure out how much we need to go for the second pass. So we're getting there. All right, we're going to make the second pass here. Had to raise the table up 192 thousandths. Seems to be taking a much more labored cut. It's settling down a little bit. Chips look all right, I guess. We are cutting a bunch of metal though. It looks all right. From what I can tell right here. We'll know more when we get through the cut. All right, I think we're good. We're gonna let that cut on out, and I think we're gonna have 3 sides of this piece done. All right, guys, we have got our groove milled on 3 sides of this casting, and I'm pretty happy with it. The measurements check out okay. Surface finish is good. You know, it's going to be just fine. So happy with this. Now I've got some more castings to do, and we still have this side over here. It's going to be at an angle that has to be milled out, but this one's going to require a little bit different setup, and it's going to be a little more complicated because we're going to have to basically rotate the part in the thing in the vise. And I got a plan on how to do that, but the biggest problem I've got is the current stack of cutters that I'm using isn't going to be deep enough to get all the way down in here. So we're going to have to change some tooling around. So I think what I'm going to do is go ahead and get the other sets of castings machined on 3 sides, and then we'll come back and worry about getting this angled slot milled out as well. So I'm not going to bore you guys. You've seen the process. I'm going to basically just continue doing what we're doing until we get all these knocked out. So we'll bring you guys back once we're ready to mill the angled side. Well, guys, we have finished the 2 larger castings, and I've started on my smaller ones now. These are the same width, but in this direction, and the groove in the center is the same, but the outside dimensions are a little bit different. As I've done a few of these, I've kind of got my process down. I pretty much right now I've got my 0 kind of set on this back side where everything's the same. I don't have to ever change that. And basically all I'm doing is on each piece I'm coming in, I'm touching off on the top, And I'm doing these cuts in two different passes. And the first one I'm doing about 300 thousandths. Let me raise it up. One, two, see, that's 300 right there, because we're mostly just cutting out the sides. And then I come in on a second pass. I'll measure that, make sure I got my depth just right. We'll come in on a second pass and dig the bottom out, and that's about a 200 thousandths pass. Another thing that I'll note, and some of you guys probably noticed this, is before I had two 1-inch cutters in there to equal the two 1-inch cutters to make 1 inch or 2 inches wide. On one of the other castings, there was kind of a place in the side where the brass was really kind of thick, and I think what happened is there was a little sand inclusion in there where some sand from the mold had broken off and was kind of buried up into that brass right there. It was in the part that I milled out. I didn't have an inclusion in the final casting, but it really dulled up one of my 1-inch cutters to the point where it wasn't cutting clean in the bottom. So I went over, I didn't have another 1-inch wide cutter, but I had some other ones that were different thicknesses, and I basically have two 3/4 inch cutters and a 1/2 inch cutter. So there's 3 cutters in there now, still equals 2 inches wide, same results. Kind of hated I had to do that, but you do what you got to do to make it work. And the cutter that's dull, I mean, I can get it resharpened, but the outside diameter will be a little bit smaller, and I just need to get through this. And fortunately, I had that viewer from Alaska send me a whole bunch of these different cutters in different widths. So I just had to come up with a different combination to get to the 2-inch wide. But so far, we haven't had that problem since, and everything's been going good. This is the first of the 2 smaller castings that I got to do. Um, and this is the second side. But I just kind of want to give you guys a quick update of how it's going. Now that I've kind of got everything set up and rolling, it's going pretty quick. At first it was kind of like, all right, we kind of have to figure things out and get things set up. But this is not taking too long at all. I'm just able to kind of roll through them. So anyway, we'll bring you guys back when we get through here. It's coming along good. Another little thing I'll note here that I'm doing a little bit different than the first time. When I do I've already done the bottom side of this one, and then I have the top side that needs to be parallel to it. Before, I was just laying it down on the side. When I did the first one, I went in there and measured it, and it wasn't really perfectly parallel. It was off by, it wasn't by much, but it was off by a little bit. So I kind of modified my plan, and instead of setting on the bottom side and counting on the top and the bottom being parallel, really what's important is these surfaces be parallel. So I've got some parallel blocks down here in the bottom, and I'm just going to set it on those instead. I can get them lined up. There you go. So now my setup is truly parallel to the inside surfaces, which is what's more important. It wasn't a problem to straighten out the other piece. I just had to put it back in there and get it all to the right same thickness, and we were able to hit our number right on. But I did have to do a little modifications there, and I did that off camera. But in transparency, this is how we're doing this going forward. So anyway, we are set up here now. And again, what I'm going to do is I'll come in, I'm going to touch off on this one. We'll do our first pass, get a measurement that we can measure off of. But on this one, I'll be measuring to the parallels. I'm measuring the thickness rather than the how deep this groove is. What's important is this on this one needs to be 3.5 inches. So that's what we're going to be doing. All right, that's all I'm going to show there, but I did just want to show that little change in setup. Well, there we go. That's going to pretty much be a wrap for this episode. Like I said, we still got to mill the one slot over here at the angle. And once that is done, the next step will be to get these things bored out to the proper size. And because of the fact that we're going on to a locomotive that every single pin that these will mount on is got 100 years of wear in them, we're going to probably have to, well, we are going to have to bore each one of them specifically to match the piece that it's going to actually fit up on. I will too say that, really all the milling that we've done on these so far, we've surfaced all but, the inside surface here, but Out of these, the really critical measurement is going to be the bore and making sure that it's set up properly. The rest of these measurements are really not super tight tolerances or anything like that. They just need to kind of fit. And but with that said, I think everything's plus or minus 10 thousandths, which for the application here should be just perfectly fine. Again, there's not a whole lot of tight tolerances on anything that we have done so far. The bore here is going to be the critical part we'll need to do once we get to that point. So let me, I'm going to get this milling machine cleaned up. It is really messy with all this bronze everywhere, all this swarf that we cut off over here, lots of that, get all that cleaned up. I'm going to change my cutter out over here, put a deeper cutter in, and like I said, we'll come back and see if we can do the insides of this last cut on a separate setup, and hopefully that will go as well as everything else has gone on this project so far since we've been over here working on it. So guys, with that, that's going to be a wrap. As always, thanks so much for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. And as always, a big, huge thank you to my subscribers out there, as well as those who support the site financially through Patreon, PayPal, etc. It really makes a difference and really enables me to be able to justify spending the time to shoot these videos and share them with you guys. Guys, with that, that's going to be a wrap. As always, again, thanks for watching. We'll catch you on the next video.